So welcome students. So in this question you are given that b1 and b2 whose equations are 3x plus 4y minus 7 and 4x minus 3y minus 14 is equal to 0. Bisect the angle between the lines L1 and L2. Bisect the angle between the lines L1 and L2. And L1 is passing through 1, 2 that's given in the question. So if that is so, can you talk about which of these bisectors are acute angle bisector and which of these bisectors are obtuse angle bisectors? So let us try to analyze this question. So first you know the equations of b1 and b2. That means can you find the equation of L1? So L1 is a line passing through the intersection of b1 and b2 and also passing through 1, 2. So before going to analysis, let us try to find the equation of L1. So to find the equation of L1, I can find the point of intersection and use 2-point form. Otherwise, I can say that L1 will be of the form b1 plus lambda b2 is equal to 0. So my L1 will be of the form 3x plus 4y minus 7 plus lambda times 4x minus 3y minus 14 is equal to 0. So my L1 will be of this form and my L1 has to pass through 1, 2. So using the condition I can find lambda. So if it passes through 1, 2, so x is 1, y is 2. So 3 plus 8, 11 minus 7, get 4 plus lambda times, if you substitute 1, 2 here, you get 4 minus 6, that is minus 2, minus 14 is minus 16 is equal to 0. This implies lambda is equal to 1 by 4. Lambda is equal to 1 by 4. It means L1 can be obtained by putting lambda is equal to 1 by 4. So if you take LCM, you have 4 times the first line plus second line is equal to 0. So my L1 can be found out by taking the LCM. So 4 times 3x plus 4y minus 7 plus 4x minus 3y minus 14 is equal to 0. That is equal to 12x plus 4x, 16x, 16y minus 3y plus 13y minus 28 minus 14 minus 28 minus 42 is equal to 0. So this will be the equation of L1. 16x plus 13y minus 40 is equal to 0. Before going further, let me just check whether, let me confirm whether this calculation is right or wrong. I just need to put 1, 2. So 16 plus 26. 16 plus 26 is 42 minus 42 is equal to 0. So this is okay. So this is the equation of L1. Now, so can I find whether B1 is the acute angle bisector or B2 is the acute angle bisector? So if B1 is the acute angle bisector, that means this angle is less than 90. So this angle has to be less than 45 magnitude wise. So magnitude wise this angle has to be less than 45. So let me find the value of tan theta. If the magnitude of tan theta is less than 1, then B1 is the acute angle bisector. If it is greater than 1, then B2 is the acute angle bisector. If it is exactly equal to 1, then B1 and B2 are both right angled bisectors. So let us find the angle between L1 and B1. So what is the slope of B1? So the slope of B1 is nothing but minus 3 by 4. So what is the slope of L1? Slope of L1 is nothing but minus 16 by 13. Minus 16 by 13. So tan of, let us take this as theta, half of this angle is theta. So tan theta is equal to m2 minus m1 mod of m2 minus m1, 16 by 13 minus 16 by 13 plus 3 by 4, m2 minus m1 by 1 plus m1 into m2 is, if you multiply these two, you get 48 by 13 into 4 is 52. 48 by 52. So if you take LCM, you get minus 64 plus 39. Minus 64 plus 39. If you are taking mod, the minus doesn't really matter. So effectively 64 minus 39, that is 25. So you get 25 divided by 52 plus 48, 100. That is equal to 1 by 4. So magnitude of tan theta is less than 1. That means magnitude wise this angle is less than 45 degrees. This angle is less than 45 degrees. That means B1 is the acute angle bisector between L1 and L2. So the first option is right in this case. So from the next time, look at this process. So if you have two lines, so if you want to decide whether a particular angle bisector is a acute angle bisector or obtuse angle bisector, you just need to find the angle between the line and one of these lines, bisector and one of these lines. Magnitude wise you get tan theta less than 1, then that angle bisector is the acute angle bisector. Thank you.